Today we're wrapping up one of the most unique and cool projects we've ever had the opportunity to work on. It is an Earthship. The house was built in 2004. The initial radon was 49.3, and the property is full of gold mines that date back to the 1860s. The house is built out of tires and pop and beer cans and concrete. Let's go ahead and take a look and see how it went down. Here we're in the garage, and one of the unique things about this home is this is the only unfinished space, making mitigation very challenging. Here we're in the living room. One of the unique things about this construction is that this entire back wall of the house is built out of tires. So they're tires that are stacked on top of each other, filled with dirt, and then they've got a thin layer of concrete over those. Another challenge is under this kitchen floor, there's a large opening to soil where there's a grease trap and then ball valves for the plumbing. And then here we've got this planter that runs the entire length of the front of the house. So the gray water drains in either end of this planter, and then it works its way through and waters all the plants that could be here. These walls are built out of pop and beer cans that are emptied, turned sideways, and then they've got concrete that kind of muds everything together. And then finally, we have the bedroom. One of the unique challenges in the bedroom is that we've got two cisterns outside since there's no well on the property, and the water lines from that come through and run under the floor over to the garage. But here under the bed, we've got an access panel that allows them to shut off water to each of these cistern tanks. So we had to make that accessible, but we also needed to seal it so that we didn't have any radon entry there. So like any project, we start with pressure field extension testing, and that is simply measuring the extent and strength of the suction that our system creates under the slab. So we drill our 1/2 inch and 1/4 inch holes throughout the home, and we take and record those numbers, the difference in pressure in the home versus under the concrete floor. Next, we want to figure out where do we want to put our suction points. So we do communication testing. So I drill holes where I anticipate we could put suction points, and then from there I apply suction to each of those holes with a shop vac and record the numbers that I get on my micromanometers. And I can see, hey, when I draw from here, I get the best suction over on that side of the house. Or when I draw from there, I get the best suction over on that front side of the house. So I did that. The numbers showed that we get the best communication from this suction point in the mechanical room here. We took out 27 gallons of fine sand with some rock, and then we do more communication testing. So we hook up a device called a pitot tube, and we measure how much air do I need to move and how much suction do I need to apply to hit my target pressure in each of these test holes. So once I got that for the back side of the house, then I moved to the front side and we added a suction point here. Here we took out 17 gallons of material. Then I hook up the pitot tube and apply suction to that so I can measure how much air and suction I'm applying to reach my test holes on the front side of the house. Once I had that data, I found I was still a little bit weak over here, and looking throughout the construction photos of the house was super helpful because I could see that they had dug a trench for that water line that goes out to the cisterns. So I put a suction point here, and here I think I took out like 12 gallons. Then we built this system. We knew how much air we needed to draw from each suction point. These two were just like a few CFM, like less than 5 CFM. So we built that out of 2-inch pipe. The pipe goes up through the ceiling into the attic, and then it runs over towards where this 3-inch pipe comes up. This pipe then goes straight up through the roof. We don't have the radon fan in the attic because it's a conditioned attic. So we cannot have a fan in a conditioned space, so the fan is therefore on the roof. In order to mitigate this side of the house where the bedroom is, we couldn't just simply add a suction point because it's all finished and there's not a closet or anything we can hide that pipe in to go up to the attic. So we had to think outside of the box. This retaining wall was added about 5 years ago, and we found that they put drain tile on the back side of the retaining wall. That goes down the hill to daylight here. I ran my sewer camera in the drain tile system, and I found that right here, that drain tile was about 4 feet down. So I dug a hole here, I opened up that drain tile, I put in a T, and then I ran my 4-inch pipe up to my radon fan, and then my exhaust is that high because I've got to be 10 feet above the ground. And then that drain tile system tees or ends in the corner where it meets the house there. And then on this end, since it's open to daylight, we don't want our radon fan to just pull a bunch of air from outside. We want to create suction under the soil over there. So we've got this little check valve. So it's basically just a flapper that'll allow water to drain out, but it won't allow a ton of air to enter into the system. So I could have put a weatherproof enclosure out here to put our monitoring equipment, but I'm afraid that the homeowner would not have heard that because it's super quiet inside the house. So if that alarm was going off, I don't think anybody'd ever hear it. Therefore, when that radon fan fails, we want them to know that it failed. So here we've got this conduit that ties into the suction side of our pipe. It runs up the wall and then it enters the attic. And I've got about 120 feet of tubing that runs across the attic over into the garage to our system monitors. That tubing from the other side of the house comes down here to our radon system alarm and our U2 manometer, which is our visual gauge just to tell us if the fan is creating suction. And then here is the one for this garage system. And then here we've got our ongoing maintenance and monitoring plan. The only thing that is left is for the electrician to come and wire these radon fans permanently and get rid of those extension cords. I'm Jesse with American Radon Mitigation. Thank you so much for watching.